Welcome to Summarize Science. Astronomers have been captivated by a cosmic mystery, distant galaxies called blazars that seem to pulse with the regularity of a clock. For two of these, named PKS 2131 and PKS J0805, the leading theory is that we're seeing two supermassive black holes locked in a gravitational dance. But how does their orbit create such a perfect, repeating signal that travels across billions of light years? In this paper, researchers propose a fascinating and elegant model to explain exactly what's going on. They suggest that one of the black holes is surrounded by a powerful, swirling wind. As the black hole orbits its partner, this wind is dragged around with it, carving out a giant, corkscrew-shaped tunnel in space. Now, imagine the other black hole fires a super-powered jet of particles, traveling at nearly the speed of light, which is then forced to travel down this pre-carved helical tunnel. So instead of shooting straight, the jet is whipped around in a continuous corkscrew motion, and this is the key to the pulsing light we see from Earth. Due to an effect called relativistic aberration, the jet appears dramatically brighter when its path is pointing more directly at us. As it swings around in its corkscrew path, its beam sweeps past our line of sight, creating a brilliant pulse, just like a cosmic lighthouse. When it swings away, it appears to dim, and the orbit of the black holes provides the perfect clock to time these pulses. This model also brilliantly explains another strange observation. The pulse arrives at slightly different times depending on the radio frequency you're looking at. According to their model, lower frequency radio waves are emitted much farther down the jet. Since the corkscrew pattern takes time to travel outwards, there's a natural delay for the pulse seen in these lower frequencies. The researchers' calculations of these light variations match the observed data for both cosmic lighthouses incredibly well. Their model can even predict what the system should look like if we could zoom in, showing how the brightest spot would appear to wobble back and forth over the course of an orbit. So, let's recap the important points. The researchers propose that the regular pulsing from these blazars is caused by a jet from one black hole being guided by a corkscrew-shaped wind from its orbiting partner. This causes the jet's beam to sweep across the sky, creating a lighthouse effect that explains the periodic brightening and dimming. This model neatly accounts for the observed signals, including the time delays between different frequencies. What does this mean for the future? This provides some of the strongest evidence yet for the existence of these supermassive black hole pairs and gives astronomers a new tool to understand the physics of these incredibly powerful jets. And perhaps most excitingly, these confirmed binary systems would be prime targets in the search for individual sources of gravitational waves, the ripples in space-time first predicted by Einstein. Confirming this model would turn these mysterious pulses into beacons, guiding us to some of the most extreme objects in the universe.